Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on rational equations. In the last lesson, we learned the definition of a rational expression. We learned to express them in their simplest form and to perform the four fundamental operations on them. We also learned to decompose rational expressions into sums of partial fractions. Today, we will learn to solve rational equations. Let us get started right away. A rational equation is an equation that can be reduced to the form of P of x over q of x equals 0, where p of x and q of x are polynomials and q of x does not equal 0. To solve a rational equation, we must follow these steps. Factorize all the denominators and determine their least common multiple. Restrict the values of the variable that make the least common multiple equal to 0. Multiply both sides of the rational equation by the least common multiple and simplify. Solve the resulting equation. Check the answers against the restricted values in step 2. Any such value must be excluded from the solution. Note that to solve a rational equation, we may multiply both sides of the equation by the least common multiple of the denominators for those values of the variable for which the least common multiplier is non-zero. It is important to remember that the values that cause the denominator to become 0 cannot be solutions to the equation. A number that looks like a solution but causes the denominator of the original equation to become 0 is called an extraneous solution. Let us try an example. If we wish to solve this equation, we must first establish our restrictions. In this case, x cannot equal -1 or 2. Now we multiply both sides of the equation by their least common denominator, x plus 1 times x minus 2. We can cancel x plus 1 on the left side and x minus 2 on the right side. After we multiply, we see that 2x minus 4 equals 3x plus 3. Solving for x, we find that x equals -7. This does not contradict our restrictions, so our solution set is -7. It is time for our first activity. Try to solve this equation. Remember to follow the steps we have learned. I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us find the correct answer together. Here is the equation. Our restrictions are that x cannot equal -4 or 3, since either would reduce the denominator to 0. Now we multiply both sides of the equation by their least common multiple. Our equation now looks like this. We can cancel x plus 4 on the left side and x minus 3 on the right side. Therefore, our equation becomes 3x minus 9 equals 2x plus 8. When we solve for x, we find that x equals 17. This does not contradict our restrictions, so our solution set is 17. Good work, students. Now let us try another activity in the form of a word problem. two airplanes leave an airport, flying at the same speed. The first plane flies 2 hours longer than the second plane and travels 3,600 kilometers. The second plane flies 2,400 kilometers. How long was each plane flying for? See if you can solve this problem now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us suppose that the first plane flew for X hours and the second plane flew for Y hours. In that case, we can express the relationship between the two flights as X equals Y plus 2 or Y equals X minus 2. Since they flew at the same rate, which is expressed by distance over time, we find that 3,600 over X equals 2,400 over Y. This equals 2,400 over x minus 2. This gives us 3,600 times x minus 2 equals 2,400x. We can express this equation as 1,200x equals 7,200. When we solve for x, we find that 7,200 divided by 1,200 equals 6. So the first plane flew for 6 hours. Since x equals y plus 2, y equals 4. The second plane flew for 4 hours. Were you able to solve this problem, students? Great work. We have time for one more activity. A tree casts a shadow of 50 feet at the same time as a 6-foot man casts a shadow of 2.5 feet. What is the height of the tree?
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Have you finished working on this problem, students? Let us look at your answer. Let the height of the tree be h feet. In that case, h over 6 equals 50 over 2.5. This equals 20. Now let us solve for h. We multiply each side of the equation by 6, so we find that h equals 120. Therefore, the height of the tree is 120 feet. That is all for this lesson. Today we have learned how to solve rational equations. Until next time, thank you, teacher. Thank you, students.